This is number 44 in chapter 8. I'm going to do parts A and parts B. And this is asking us to write the full orbital diagram for each element. I'm going to go do a couple different ways of representing for each one, just so that we can have some practice here. So for sulfur, we basically just need to go to the periodic table and keep filling up levels as we go. And so what we'll find is that we start at the first level, so we fill up our first S level. We would also fill up our second level as well. And then we find that now we're in the final quantum level for sulfur. And so we end up with this representation of the orbitals that exist around sulfur. And so another way we can represent that is to represent the ones that are filled as a noble gas. And so we could say that another way to represent these orbitals would be in this manner, where we again show the filled complete sets as a noble gas, in this case neon, and then just show the highest level, the highest quantum level that is not completely filled yet. And then the other way to do it is to actually show the orbitals and the number of orbitals that we have in each one. And so here's what this would look like for showing the actual orbitals themselves, noting that for s orbitals there's only one, and for p orbitals there's actually 3. And so we just need to fill in electrons from left to right, and first we put in one electron pointing up, and we do that until we run out of slots, and then we pair. And so the 1s only has one slot, so first we add one and then we pair it. Same happens with the 2s. For the 2p, we would put these all in first singularly, because there's 3 of these p orbitals, and then we would pair them up. And so that would be your actual orbital diagram for sulfur, just showing it more than one way. For calcium, we have something very similar. We could again represent it by just showing the orbitals and how many electrons are actually there. And so that would be our electronic configuration for calcium. We could also use the noble gas method for representing that as well. Again, the first, the second, and the third levels are all filled, so that would be isoelectronic with argon. So we represent that noble gas, and then what shells, what quantum levels come after that noble gas, in this case 4s2. And then the real answer to the question is, again, drawing the actual orbitals for each one. And so we have our 1s, our 2s, our 2p, 3s, 3p, and 4s. And again, we always wait for pairing to the end of filling up an orbital, such as our p here. And that would be the orbital diagram for calcium. So we're really just putting this in order as we see these appear on the periodic table, and we're just simply filling these up from lowest energy to highest energy.